section of AP enrollment. I'm sure you all know AP courses are high school courses that give you college credit or placement, one or the other. And most of the numbers that were bringing dollars in, at least in students into the AP program, were from the history, English, and science, and math, the big four. Computer science was down here, the really small slice, about 20,000 people, really, really small slice of the students doing that. And in fact, it's even worse. It's not just we're small in the global perspective, which means that most students around the country aren't getting computer science or even having the availability of it. But if we take a slice of that, it's really remarkably underrepresented. These numbers should be 50% for young women and roughly 23 to 26% for students of color. So really remarkably underrepresented. These courses were in rich suburban white and Asian schools, essentially. This is not in the inner cities, not in the rural areas. This was not a class that was being reached by most of the students across the country. So Jan Cooney with Lynn Diaz and Owen Astrakhan and Amy Briggs all thought about what could we do to bring computer science to everybody. And this was, again, their leadership. I came in later to that, but those four people got a National Science Foundation grant that Jan helped write, which helped think about, just give you a sense of it, in summer 2008, there were two courses, APCS-A and APCS-AB. AB was like A with a little extra, kind of data structures, more like the CS2 class on campus, the second course for majors, data structures. And that was even, I mean, it was, they set records, by the way. They set records for the most gender-skewed course. The ACS-AB had the most gender-skewed course in the history of the College Board, like the almost 40, 50-year history of the College Board. It was just terrible in terms of diversity. So they dropped it. They dropped AB. So now there are one. They said, well, we can't keep two courses. We just had one. But then Jan got this group together in October 26, 2008. And she said, should we think about a second course? Or should we change the first course? Should we change CSA to be something different? Or should we add a second course? And there were enough people who said, no, A works for us. They had high school and university folks. And they said, no, A is perfect. It's perfectly aligned with what we do. Don't touch it. It's in Java. We're happy. So, okay, well, how about a new course then? And this course was born that day, October 26, 2008, Computer Science Principles, with the idea of it being a course that the entire campus could take. So it's a junior level course. We called it CS0. So it modeled what you teach as in a non-major course in university. And the idea was there really was normally when they make an AP course, they look, let's say AP Physics 1. They look at what's being taught in Physics 1 all around the country in the intro courses. And then they kind of figure out what's the book that's being taught? What are the topics? Oh, I guess it's Newtonian mechanics. And then they build a course around that. But there really was no universal agreement on what the CS0 course should be. So the idea would be, well, what if you had a couple of national pilots, and we got chosen as one of the first 5 national pilots, that were models for what could happen. So I ran back to Berkeley October 26, 2008, and Brian Harvey and I said, erase the whiteboard. We took our old course, CS3, which is 3L, which is a lab-centric. Many of you know Mike Clancy. So we had converted to a lab-centric course. We believe that lab is where you learn. So we said, let's keep the best things about 3L, like powerful CS ideas like recursion, functions as data, scheme elements, but switch it on its head, maybe bring a graphical language in there. So that was the idea. We wanted to take this new model, the CS Principles course, and we wanted to be a national model for that. So this is a video. As I'm pausing this, can you hear that? I just wanted to make sure that you guys can hear that. Did you hear anything when I played that video? Anybody?
No, I don't.
No, we didn't.
Zoom. Why has that forsaken me? Okay.
Dan, when you first go into share screen, there should be on the bottom left a checkbox saying include audio.
I'm gonna get out of my PowerPoint. Okay, stop share. I'll go back to thank you for this. Okay, so now I click share, and share computer sound. Thank you. That's outstanding. Optimize for full screen video clip. Sure. Share. Thank you for this. Never saw that before. Clicking share. Please install the Zoom audio device. I now have to restart my audio sharing application, such as your media player, after install to continue sharing computer sound. I just clicked that button and I don't know if it will work. In the background, let's give it a shot. I'll go back to here. Okay, but thank you for that tip. That's good. I hadn't tried that before. I did not know that feature. Here we go. And I'll do it again and then pause and see if it worked. Any luck?
Not yet.
Not yet. Okay. I can also say what they're saying. There's a musical theme behind it, but I could. What you tell me what to do at this point? Should I go ahead?
Just voice over.
Just voice it over.
I think so.
Yeah. Okay. Well, that's good to know that was in the future. If I restart everything, it might actually work. Okay. Let's see. I've seen this enough time. I think if you start this everywhere. Smart medicine that can monitor your body, national security issues, sonar technology to view the inside of your body. Save lives. It's helping people. Computers have transformed everything we do. Computer science principles is a broad introduction to computer science. It's not about syntax, it's about creativity. They can read and understand how the internet functions. By the time the course is over, they'll have several apps that wouldn't exist if it wouldn't for their learning. I ask my students to look at the world and to think about things that are in that world in terms of data. They can actually understand how instructions are given to a computer. We went to talk about how the internet works to where the first computer bug came from, an actual bug. People from the basketball team, football team, people in interior design, theater, tech people. So.
They want to learn about music, I'll teach it to them on a program that has to do with music.
I felt like I was in the studio just making a hit for everyone. This is what I've been waiting for forever. Just showing your flavor, just showing everything through code is just amazing.
Being able to press, enter or run and see my world pop up.
It's just like painting or drawing.
My cursor is your paintbrush.
A lot of girls are intimidated because they see computers as like a guy thing. If more girls were like encouraged, then that wouldn't be an issue anymore.
You don't even think you're creative. And then you have a course that makes you see yourself as creative.
It kind of feels like a new light has turned on.
Computer science, I feel like, has really helped me with my confidence.
The biggest change I see in students is their confidence.
This class teaches kids how to think.
Computer science can empower. Computer science is a source of making that could lead to that power.
My friend and I, we just look at each other, we're like, oh my God, we finally got the code.
We have breakthroughs, we make discoveries.
Wow, a bunch of ones and zeros did that.
Coming into that class and seeing I can design my own thing is such a powerful thing. Awesome.
How did that work?
Yes.
I'm sorry, I didn't think about that earlier. Okay. So, CS Principles was born, and it was founded on two pillars. One, big ideas. These are things that you know, and to have creativity be listed in a computer science course is the first time I had ever seen creativity listed as one of the learning goals of a computer science course. Abstraction, the most powerful idea in computer science, was there as well. So proud to have this list. By the way, I was on the advisory board as this was getting created, and data information, algorithms, programming, the internet. The internet used to be called systems, like how computer systems work. It's not just one computer, it's a whole system. And people said, well, there's like microsystems on a chip, there's a million computers running Facebook. What system do you level? So what level do you mean of systems? And so they changed it to the internet, and that was a little bit cleaner. And finally, global impact, how computing impacts society. So proud of that. And that's also the first time I'd ever seen a computer science course talk about that. That wasn't an ethics course. So that was really exciting for many of us. It's also anchored by what you do in the course. These are computational thinking practices. Jeanette Wing of CMU and National Science Foundation wrote an article about computational thinking, and many people jumped on that as that's what we really should be teaching in K-12, not coding. So these are the CT practices that we did. You're connecting computing to other fields and to your interests. You're not just reading about it like a fishbowl, but you're also building artifacts. You're building programs that are interesting to you. You're using abstraction. You're not just reading about what abstraction is, but you're also doing abstracting yourself. You're analyzing problems and artifacts. Maybe this piece of code only works if the numbers are positive, or doesn't work if the list is bigger than 20. And these also last two elements I've never seen in a computer science course, where your explicitly learning goal was to communicate the results to others, other students and other instructors, and collaborate with other students. Just so proud to see those two elements. So there are lots of pieces to this course that I had never seen in a CS course. Really, really exciting. So that was CS Principles is a framework. That was a curriculum framework, which means that any curriculum designer can then build a course that adheres to the framework, that's compliant with it. So we went back to the drawing board and created BJC, Beauty and Joy Computing, and we wanted to distinguish ourselves. And what distinguished ourselves across other courses, some were focused on app design. There was a mobile CSP, which focused on App Inventor. Then there was an Apple iTunes CSP course, which focused on building things on the iOS platform. There are different Code.org has a group that works when they're in the browser system. What made BJC special was we took a programming lens. When we interviewed our students from 3L and we said, what's the most fun you had this year, of the whole year? They said, when we got to program our own project at the end of the year, when we actually got to do the coding. We said, well, if that's what they want to do, let's stay, let's not, by the way, many of CS Principles courses took the lighter end versus, coding is what people don't like about CSA. Let's make it learning about it, and coding is the minimal. So they kind of on that spectrum, they chose the minimal amount of coding to just barely get them over the hump. We actually chose almost the max amount of coding. It wasn't a coding class, because we obviously talked about the social implications of computing, as I mentioned here. But we took a coding lens. For example, learning about the internet. Most of the other courses just watch videos about how the internet worked. Well, we wanted to actually see if you could program the internet. Are there internet APIs that you could call, which make a request to a machine in Japan, bring data back, and then do something with, and then maybe trace the hops that you took to get there? That's the element. So it wasn't like the fishbowl model. It was really learning about things in the world by programming them. We also wanted to keep the things we loved in CS3L I mentioned. Recursion, we wanted to see it can be taught. Nobody else, not a single other course was teaching recursion. And the part that was a little bit of a challenge was these elements were not in the College Board's requirement. These are things above and beyond. So there was a tension. Do we teach these before the exam or after the exam? Some of us wanted to make sure that they were taught before the exam, so they just were part of the normal course that you learned. Others felt that if you taught this before the exam, then you're kind of taking time away from maybe exam prep or other things they could have maybe gotten a little bit more solid foundation. So some of us were arguing to put it after the exam. So you take the exam, and then you've got a month afterwards for some classes. Some of you only have a week, but some of you have a month. So we'll do these things at the end. So there was a tension of where this actually lives in our curriculum. Graphical language, we decided to work with Scratch and then make a modification to Scratch. I'll say that in the next slide. We just really, really love that as trying to make preserve the things we liked about Scheme, but also love the interface that Scratch and the modality that Scratch brought. We also, really, the global impact. Brian Harvey had been teaching for many years a course called The Social Implications of Computing. And just around the same time, Blown to Bits, this outstanding book by Abelson, Ledeen, and Lewis, came out. And we realized, let's use this book as part of the foundation for our social implications of computing. And the idea is that technology isn't all positive. Technology is neutral. And there are ways to use technology in a wonderful, positive way. You can connect people on Facebook that are across the world who have similar interests. You can also weaponize the populace, as we've seen in the last election. So technology is out there as a neutral thing, but you can spin it both ways. So it is balancing optimism with pessimism. So another thing we talked about is we brought computing in the news every single day. So we call these bell ringer activities. So the moment the teacher clocks in, they have been leafing through the New York Times, and they'll bring this up, and they'll bring a topic up. So this is a slide deck that we would bring up in CS10. We'd only have 2 lectures a week, so we would talk about this. So this is talking about how automation is taking over jobs, and a quarter of the jobs are possibly at risk. Here is ordering from fast food. This is Amazon. This is the Amazon warehouse. This is a floor cleaning device, I think, in Walmart. And this is a ramen maker made out of robots that are making ramen automatically. Here's an example. Sometimes we talk about a new technology that's coming around. Many of you know about Netflix and streaming video, but the idea is you're still going to GameStop and other places to ship you a disc or a chip or SD card to play your video games. The future might be that you're streaming a video game. So there's a server that's rendering the screen. It's sending the video to you just like Netflix was. And then your key commands, your clicker, your button presses are being sent to the server. So the game is being played remotely, and so you'd never have to actually download any media anymore. So they're trialing this, and that's it. So sometimes we talk about, oh, this is a new news, and people are pushing on this new technology, which is interesting. And sometimes you have some nice innovations. This is the idea that you don't have to go into an optometrist anymore. This is with augmented reality. You can, and Apple's new feature, you can see what a set of glasses would look like. And she's changing the set of glasses down here, and she's seeing how it looks like on her face, and she turns her head back and forth using augmented reality. Pretty cool. So that was an example of kind of how we bring computing in the news to the class every day. So as I mentioned, we've used our language, the language we've been using was Scheme, and we decided that a text-based language wasn't going to cut it in the new age, new era. So we wanted to think about a blocks-based language, and we looked at many, many options, Blockly, Alice, and we settled on Scratch. We really, really, really love Scratch, but the problem was Scratch had a ceiling. Scratch talks about having a low floor, high ceiling. We didn't want any ceiling, meaning there were some things that Scratch by design you couldn't do. You couldn't write a function. So if there was a function if I had a couple of blocks together to draw this fractal, I couldn't say this is the dragon curve block that does the whole thing. When I click on it, it draws this. They didn't allow that. So Jens Monig, this is a picture of Jens here. Jens was a programmer that worked with Scratch, and Scratch was open source. So Jens had taken a version of Scratch and added the ability to write functions in there. And we said, that's great. He'd called it BYOB, or build your own blocks. Well, we took that and we used it for a couple of years, and then we actually rewrote it. Often you take something, it was too tied to the way Scratch was done internally to be able to make some changes we wanted to make. So we ended up rewriting it in JavaScript. So here's an example of running this on an iPad. You can now run this on a device. By the way, the same month we made the decision to rewrite this in JavaScript and HTML5, Scratch made the decision to rewrite Scratch 2 in Flash, just when Flash was losing its support with mobile devices. So here's an example of how powerful this language is. It's hard to see this graphic. It's a little bit fuzzy, but this is a for loop. And I've given this talk, probably 40 times around the world. And I ask many times as a room of programmers, and I say, pick your favorite programming language. And how many of you, if a for loop, if the for construct didn't come with the language, could you build a for loop and then use it seamlessly as if it had been part of the language? And almost no one raises their hand with that. And here it is. Here's us doing this, a for loop that we're building here, and here is a nested for loop used just as if this for loop had come from the system, but in fact we wrote the for loop. So that's really wonderful and really powerful. So for language geeks, Snap is really, really powerful. We think of Snap as being the love child of Scratch and Scheme. So it has all the best benefits and best affordances of both. So this is actually a slide from an actual lecture in CS10, the Berkeley version of the course. Obviously, this has been run in high schools as well. People have taken our course and moved to high schools. I'll talk about that a little later. But this is an example of how we teach recursion. So you say recursion can't be done. Let me just walk you through how this works. So this is a sprite. This arrowhead is a sprite. The pen is at the tip of the sprite. And when the green flag is clicked, here's what's going to happen. We go to this position, go to the bottom center. We point up. We show it in case the sprite was being hidden. We show it. We put the pen down. Now this is called turtle geometry. So as this sprite is going to be moved around with these move and turn times, move and turn blocks, you'll be drawing lines on the screen. So we clear the screen. We call the V block. What is the V block? This is the definition. This is called a hat block. It's kind of shaped like a hat. So this is the definition of V. So these are the blocks that are part of V. Turn left 20 degrees. So now it's facing this way. Okay, facing left a little bit. Move 25 steps. Boop, moves out. Then it runs item random of shapes. Well, shapes is a list. You know that these are blocks, as you've seen them here. So this is a list without any difficulty. Students know that this is a list of blocks. There's a gray border around them which says, don't run the block now, run it when I actually run it. So it's a way to put blocks in a list without actually calling it there. It's called thunkification. It's a way to thunkify this. So we pick one of these blocks and we run them. So I pick one of these random things, square, circle, or triangle, and it runs it. So it draws a little thing here, wiggles around and does that. Then it says move minus 25, which means it backs up, still facing up and left. Turn right 40 degrees, and now it's facing to the right 20 degrees. And then basically does the same thing again. Moves out, runs one of these ends, and moves back, and then resets. So it ends up, this is important, it starts and ends at the same exact place. But maybe it drew this V, and maybe the V has these little decorators at the end. Let's try it. Let's run it once. And we run it. So this is fun to run this live in class. We click the green flag, and oh, by the way, before I do this, I want to note that Snap is available in other languages as well. Scratch and Snap are both multilingual. This has multilingual support, so we work with 35 languages. I've given this talk in China, and I actually had a standing ovation the idea that a student in a rural part of China wouldn't have to learn English. This is just V. I typed the word V, but they would have typed some equivalent pinyin or something for V, and this entire thing would be in Chinese. And the whole interface is in Mandarin as well. So it's pretty exciting for them, and folks have given us standing ovations when we've shown this in the past. Okay, so let's run it. Ready? Oh, look at this, very exciting. It drew a circle and a square. Boy, that kept you excited for about 20 seconds. And I'm running it again. Oh, okay, look at that. Yes. And this is, by the way, the first time the students ever seen a program that surprised them, because there hasn't been any randomness. This is item random of shape. So this is the first time any program has surprised them. So they kind of get a kick out of that, but it's not very exciting past that. But they get it. And so now I ask the students, this is the fun thing to ask in class, what happens if I add V, itself, to the list of blocks that V could choose on these two runs? Here's V. I've added these two purple V's to the list. When it adds a green, it just puts a decorator. When it chooses a V, who knows what happens? And so this is what we always ask in class. Now, take a second. I'll actually pause for maybe 20 seconds. I'd like you to predict in your head, maybe even sketch it, what would happen when I run the V block. And I'll pause, think and predict. This is like Marsha's case study. Now think and predict what will happen now if I click this button. All right. Let's see what happens. 1, 2, 3. Oh boy. Well, both times it happened to choose the green endings. That's fine. Let's run it one more time. Oh, you get this collective as the students all take a breath in at the same time. And you'll see that it went left and picked V again, which itself makes it a left and has its two endpoints. And those two endpoints happen to be the green ends. But look at that. There's a V that called V. And if we actually call this one more time, we'll see that sometimes you get a really beautiful, just run this one more time, and look at that. Notice I didn't change the V program. This is, by the way, not my demo. I need to give credit where credit is due. This is Paul Goldenberg. If you remember, Paul was one of the first people at EDC. Paul created this program for Logo, some 30 years ago. And when we went to Scheme, we went to Snap, we just said, let's bring that demo back to teach recursion. I just think this is a delightful, delightful version. If we actually show it a couple more times, you see there's a whole forest that can come up. And whenever one of these comes up as the first one, if usually nothing happens, then some big, bushy plant comes out, and that's when the whole class goes, oh. And this is, by the way, this is when we realize very rarely do we tell our high school teachers to lecture. But this is one mini time where it's great to have the same reaction at the same time. You don't want to have 20 people all going, oh, and people go, what is that? What is that? Wait, no, oh, well, click the button. Da, da, da. So this is a nice thing to have a collective shared experience for that. So that's how we teach recursion, using blocks and using Paul's demo. Now let me continue with some actual slides from our class, just to give you more of a sense of what we do. This is a set of blocks: repeat 4, move 25, turn 90. Let's assume the pen is down for all of that. I'll ask you what this draws, and we kind of pretend to be a robot and walk around in the sand. And this draws a little teeny square whose side is 25. I showed you this one, and I changed only one thing, and I might ask you, what does this draw? And I'll pause for a second to think about it. And you're probably all right. It draws a little bit bigger square. I do it one more time, and again, I change only that number. You might say, well, Dan, where's this going? Well, it draws just a bigger square. And a student might come to you, and you're the instructor now, that might come to you and say, look, I drew these big 3 squares. Look at this. And I've got 3 copies of the same code. One of the principles we have in computer science is DRY, or don't repeat yourself, meaning don't have copies of code that is the same piece of code to 2 different places. Put those things, collapse them into one place, and use abstraction to do that. So let's show you how we do that. That's that 395 for that. Let's show you how we use abstraction. So one of the things that did not come with the first version of Scratch, they've now since added it, I think thanks to us encouraging it for years and years, is you can make your own block. These blocks that we're using don't come down from the mountaintop on 2 tablets. You can make them yourself. And so here is draw square of side length. This length is like the 500 hats of Bartholomew Cubbins. If you keep dragging this out, you keep getting more length. So if in case I need to use length several times in the block, I can keep dragging this block and dropping it here and dropping in the slots. You notice the only thing that changes here are the 3 steps as the number for the steps. And so this length is a parameter. The 2 parts of abstraction, one is generalization and one is detail removal. And in fact, this block highlights both of those. the generalization is this parameter allows for drawing any size square. There's the generalization. The detail removal is this parameter, if I just use this block, I can actually take this away. In fact, Scratch doesn't let you do this. If you played with Scratch recently, they force you to keep the definition of the block on the stage, like on the programming area, not the stage, but on the script area. We allow it. When I'm editing this, I can say, okay, this goes away, and then I don't even know how this worked anymore. Does it matter? Nope. All I need to know is what it does, not how it does it. This is showing you how it does it. But if I just click this and I have a spec, I have some documentation for that, all I need to know is what it does, not how it does. So that we kind of highlight both of those elements of abstraction with a single slide. And this is all great. And by the way, everybody teaching, you have to teach abstraction in CS Principles. You saw that earlier. That's the second big idea. So every single class has a slide like this or has a set of lessons like this where we teach students how to write functions, okay? But only we can do the next one. I think I've surveyed 10 different courses of CS Principles, and only we have the answer to the next question, which is, well, then, Dan, the next day, the student shows you this code. Here's repeat 4, and they make a block called draw line. They take, they take to heart the idea of power of abstraction, and they write a draw line block, which basically says pen down, move something, whatever direction you are facing, and then pen up. So that draw line 100. So if I were to call this, I then get a square, just like before, so I had 100. But then they decide, you know what? Why don't I change what the line drawing function is? This is going to then somehow put the pen down and up and move, from 0 to 100, facing the way you were facing, but end up not drawing a solid line, but a dashed line. So now what would happen there? Well, you get a dashed line, square, kind of pretty. And now you say, well, what does this one do? Here's a wiggly line square. That's interesting. And so they have some kind of way to draw a wiggly line, whatever that happens to be. And this is your wiggly line square. And before I showed you this and I said, principle of DRY, don't repeat yourself. You can collapse those into one block. And I asked 9 other curriculum, what do you tell your students when you have your student walk to you and show you these 3 different blocks? Draw a line, draw a dash line, draw a wiggly line. The only thing that's different is that green block. Well, so somehow you need to write a function here that takes in the thing that's different. Before, the thing that was different was the number. So you took in the number as the input to that. But what's different here is the block itself. So how do you pass in a block itself to another block? And nine curriculum all put their hands up and says, we don't know, we don't teach it. And that's unfortunate. Well, you gotta be able to pass the block in. So we do that. And this is what, I give this all the credit to Brian Harvey, who came up with this model. This is just an input like before. And the way you do it, this is his version. This is Brian's vision. I just love this vision. You take the block, but you don't want to be calling the block. Somehow a block has to contain another block in terms of passing it in. So there has to be a hole here where I can drag a block into that. But I don't want to call it, let's say the block is the plus block, plus 2 and 3 or something. I don't want to call 2 plus 3 now, get 5 and pass 5 in. I want to pass in the 2 plus 3 block that has no inputs, and then when it's called, just renders 2 plus 3. So that's called a reporter block. These are command blocks. But the point is, I don't want to draw this wiggly line now with no inputs. I would draw a 0 line. This would be interpreted as a 0. I don't want that. I want to pass the block itself. So the analogy we use is if I were to send an octopus to a friend across country, I don't just walk up to the post office and say, here's my octopus. It has to go to New York City. They say, I can't transfer octopus. Say, well, what you do is probably bring some cellophane or something. You bring some plastic wrap and you'd wrap the octopus and you put some food in there so the octopus can survive it, maybe a little water so the octopus doesn't dry out, and then you'd send it. So the idea, once you wrap something with cellophane enough times, it kind of looks gray. It starts clear, but thick enough cellophane ends up looking kind of gray. So that's the idea. This gray border is essentially the way that we're saying, don't call this right now, call it later. And the way we call it is with the run block. You saw that before with run item random of. So run, we saw it before. So line drawer is going to contain that block with a gray border around it, which means it's just the block itself. It's not the call to it. It's not the return value from that call. This is a command. There is no return value. This is the block itself. And you run that block. Well, then there's a hole here. How do you stuff that input? Well, let's say you have this block has multiple inputs. This set of arrows, you can change left and right to change the number of inputs. If it has no inputs, you just run it. If it has just one, you just click it here. So it has one hole. You type the number in. and then this passes into this. So obviously we locked in 100 here. We could have parameterized this as well and had this been another parameter to make this even more general. I just decided to make it easy for this one. But the point is this 100 gets passed into that block, whatever that is, which gets stuffed eventually to this hole, and it just does it. So here is a way that we have solved to be able to resolve this situation, to have 3 different blocks, I can now draw a generic square. By the way, the solution, many other curriculums say, well, let's make a generic draw line block, and let's have the length as a parameter, and how dash as a parameter, and how wiggly as a parameter. And I say, well, that's very nice, but then let's say you want to make a line drawer that's, the Tiger Woods trying to pass a DWI test, a very random one. All these are not random. So a very random kind of line that eventually gets there, but kind of has a drunk person's walk there. Well, they didn't have that parameter because they hadn't thought of that. So the idea of just trying to make a very generic draw dash line with all these parameters you're passing in doesn't work because they can't handle any generic thing that I didn't think about when I actually authored the block. So this is the most simple and abstract solution we could think of, and it's really very elegant. Then that was all talking about blocks that are command blocks. We actually think about something even more powerful, which are reporter blocks, arguably more powerful. So I've given this talk, I said many times, and so often I'll have a room of, say, K-12 teachers, and I'll say, write a function now in any language. The input is a list of salaries. So here's a list, by the way lists are represented, here's a variable called salaries. When I click it, it kind of speaks its value. Again, this is the benefit of Snap and Scratch having that. And it's telling you it's a list of 3 elements. These are the indices, 1, 2, and 3 of the indices. Everything starts at 1, by the way. We're not 0 index, we're 1 index. We take that from Scratch. We think that's the right thing for beginner programmers, even though the moment they leave this language and go to C or Python, it's 0 indexed. But we think for beginner folks, that's the right call. It's the right design decision. And here's three numbers in a list, 1, 7, and 12. You can imagine this is a list on a tablet. And the input is a list of salaries, and the output should be a new list. You're not going to modify this list. It's like you're making another sheet, and the other sheet is going to be everyone gets a COLA update, and we're going to double all your salaries now. So 1, 7, 12 should become a new list when we call double salaries on the input list. Salaries wouldn't change, and doubled salaries would report. You're going to return a new value, report a list in which all the elements in the original list have been doubled to be, in this case, 2, 14, and 24. So I now say, go, work in teams. And so typically I do is I walk around the room, and what I'll actually do is collect them. This is fun. So I have people write on a sheet of paper, don't put your name on it, and I collect all of them, and then I sort them into different piles. So I'll pause for maybe 30 seconds and let you think about how you might write this, if I actually pressed you all to do this, and then I'll show you what I've seen in the past. So I'll wait for, Brian Harvey's taught me to be comfortable with the silence. So I'm just gonna wait for 30 seconds as you think about how you might write this. I'll look at my timer, see how I'm doing with time too. All right. So most of you have a little sketch of what you might do. This, by the way, you can write it in pseudocode any language you want. That's the other nice thing about this. So what I mostly have seen, so when I've collected these, this is an example using a for loop. Most people think about a for loop. If you're programmed in C or C++, it's all you think about is for loops. So let me just walk you through what this would look like if I try to do the equivalent thing in Snap. So here's my input list, salaries. Script variable is a way to make a temporary variable. It's initialized to empty. So here's double salaries. That's the thing I'm going to return. I'm going to return that thing. We call it reporting. And I'm going to set this to empty list. This is a list. I can click on this arrow and add more elements, but this initializes this to be an empty list. And then for index, meaning the index is going to be 1 to length of salaries. So for 1 through 3, I'm going to add, this is a green block. I just wrote double. Double is just times 2. It takes a value and then returns double that value. Very simple. So I'll just keep that to make it simple. So I'll add double item index of salary. So this says go to salary, go to that item index. So the first loop through this is index is 1. Item 1 is the number 1. Double 1 gives you 2, and I add 2 to doubled salary. So now I have a new list in which I just have a 2 at the top of my list. I do it again. Index is now the second number, 2. Item index of item 2 is 7. Double 7 is 14. Now this is a 14. Does it again the third time. Item 3 is 12, doubling that is 24, and I get 2, 14, 24. And when I call this, it works. It works perfectly. Nowhere here did I modify the original salaries, so that checks. And this set of, what is it, 1, 2, 3, 4, 5 lines does what I want it to do. Pretty good. And so most people have a for. Some people have worked in a language that has for each, and the affordances of for each is that you don't have to worry about the indices anymore. It's like your code gets a little cleaner. The first 2 lines are the same. We initialize doubled salaries to be an empty list. And then for each, and this actually almost reads like English. We just love, I actually think that Snap is closer to pseudocode than even Python is. And the reason for that is blocks programming, at least in this particular case, you can have the input between English words. So in Python, you'd have to have long function name, input, 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 input. But here, look at this, add this value to this list. Reads like an English sentence. And so you really can read this like it does English. So for each salary of salaries, so 1 by 1, 1, 7, and 12 are going to be salary, every loop of them. Add double salary to doubled salaries. So now you take the 2, the 14, the 24, you stuff it in doubled salaries, and you return that, and it works. So we're feeling pretty good. And so I've got, let's see here, 1, 2, 3, 4, 5. Didn't change the number of lines, but it looks a little cleaner. I don't have to worry about all these numbers, 1, 2, 3. I can just think of the values themselves. And it also reads like a sentence for each salary of salaries. So it's pretty good. Now, I've given this talk, as I said, a few times, and there was one time I said, can we do any better? So this is the next slide, can we do any better? And we go back, and I remember a teacher, I remember exactly where I was standing, and a teacher in Kane University in New Jersey said, we can do it in two lines, just kidding. And I pretended to get angry. I was like trying to act on this. And I said, did you just say 2 lines? And he said, yeah. And I said, why did you say 2 lines? He said, oh, I said, why did you say just kidding? He said, well, obviously you can't get any fewer than this. I mean, this is the 5 lines, and where else would you cut out? You got to process through the list. You got to do this. You have to do this every time. So I say, well, let's now write, so what I've taken to doing, by the way, this is a shorter version of the slides, is telling, if I have a longer workshop, I'll say, all right, write triple salaries using salaries. So what they'll do is they'll copy this whole thing, and they'll write 5 more blocks, triple. The only thing that changes is double becomes triple. And I say, now write quadruple. And they start to get it that, wait, maybe there's a more general way of doing that. So what they do is they add like a multiplying factor in here. And then say, okay, interesting. And so then I said, well, did you get the idea that, like, after showing you how, draw square, draw dash line square, draw wiggly line square should be collapsed into one? Do you get it that maybe you can have like a multiplier factor? I said, yeah. So they add that. This would be the multiplier factor. And then I say, well, how about add 1 to everybody's salaries? And they go, nope, because they've only had a multiplier factor, not a constant add, or maybe the sign just sort of every salaries. And they start to realize the more generic version might be the function you apply to every salaries is the thing you want to do. And so now you start thinking about the thing that you take in is not a number like the multiplier or the additive factor, but the function you apply to every salaries before you stuff it into this return value. And that's exactly what we do. This is 1 line. And this comes with Snap. Map is a delightful function. We call it a higher order function. It's a function that comes built in with Snap. And I'll talk about how young students, I've been teaching a middle school version of BJC to a group of local students, and I had a 9-year-old who was able to use map and work with it and do it. It really was remarkable. So map is a function that takes a function and a list, applies the function to every element in the list, here 1, 7, and 12, and then returns a new list, just like we said before, of that. And by the way, Python supports this. This is what it would look like in Python. Double salary for salary and salaries. This is called list comprehension in Python. So this is a way to do this in 1 line. So that student, that teacher in Kane University who said you can't be done in 2 because there's no way to do it. Well, what if you wrapped it all into a block and just hit it from the user? You're doing something to every block, to every element in the list. This is what you're doing it to. You're doing a double on it. I said, wow, that could be sign, or that could be times 10 plus 1. Delightful. So we teach this in BJC. In fact, this is one of the things that we brought before, this is the next thing, we brought this before the AP exam. So recursion ended up losing the argument. So recursion we pushed to after the AP exam, but we actually teach, when we're doing, data and information was one of the second big ideas, and we teach this as a way to process data. And just another FYI, map and reduce. Reduce is a way to take a list and maybe add them all up. If I wanted to add these up, I'd reduce these. We call it combine. You can combine these all and do that. So you can kind of collapse a list into one thing. You want to smush them all and separate them by column, by commas. You can combine with the comma. So you can combine with a plus. You can combine with the times. So it combines a way to take a list and then smush them all together. You have a list of things and you want to make a union of them. You can make a union procedure to do that. You can make an intersection. So you can do this and kind of collapse a set of elements of a list into one thing. So if these are Booleans, you can AND them all. So map and combine are like map and reduce, and map reduce is what Google uses in their data centers. So we're teaching this really powerful paradigm that often isn't being taught to undergraduates. If you're lucky, you learn that in somewhere in your 4 years as an undergraduate CS major. We're teaching map, and we also teach combine to kids who are in 10th grade who are 17 years old. So really, really powerful CS ideas. This is part of the idea of a beauty and joy of computing. This isn't just the fractals you produce are beautiful and joyful. No, the code itself, the elegance of this, the power of it is really beautiful and joyful. So let me talk about some perspective of teaching this at Berkeley. So this is CS10. All the 10 courses you know are courses for the campus, non-majors courses. Physics 10 is Physics for Future Presidents. So this is the percentage. We did a deep data dive. This is the percentage of women taking our courses for major. These kind of, the history is 60 ABC and 61 ABC down here. And notice it's kind of waving. You know, there's a .com boom over here and there's a boom over here, but they really don't change much past 20%. You know, it's like 20% plus or minus 10 really, between 10 and 30, wiggling here. And by the way, I don't know if you know this, but the campus only started recording gender of their students enrolled in classes in 1993 in the spring. We could get no earlier data for that. So we don't know what the numbers look like, but since recorded history, this is the numbers we have. So it's about 20%-ish, plus or minus 10 for the courses, the major courses in CS. And this was CS3 and CS3L. So this is the 3 and 3L. And you'll notice it's kind of wiggling around 35%, plus or minus maybe 10 as well. So maybe from 25-ish to 45, but we never ever got to the hallowed ground of 50. So we then looked at what the data was for CS10, the beauty and joy computing, and we found that it wiggles around 45% is about the mean, and it wiggles up and down, and we actually, for the first time in history, eclipsed 50% in the spring of 2013. Now, I'll tell you a fun story about social media, how this works. Many of you know Emoju Miller. Emoju Miller was our own PhD student in the program. And Emoju was sitting at a keynote at the Richard Tapia Celebration of Diversity Computing when I gave this keynote, and I shared this. I shared this number. I didn't have these two. This was the moment it just happened. I just gave a keynote for Tapia and I shared that number. And Emoju was a big social media person, so she shared, you only have, how many, 140 characters or something? So she shared something like, UC Berkeley, more than 50% women in CS. Now, just because she was so limited to the actual number of characters she should share, it implied that all of UC Berkeley had in CS more than 50% women. We're not Harvey Mudd. That certainly wasn't true. Our Carnegie Mellon or people who can do selective admissions. We don't have that. It was in one course for the first time ever. Well, I got phone calls from everyone around the country saying, tell me about this. And I said, well, let me correct you first. And they said, well, now that I have you on the phone, let's just talk about what you've done anyway. And so that got a little bit of press. But it's funny how social media goes viral in the sense of this was actually misinformation, not intentional, but misinformation that I had to correct. But I got some press anyway as a result of that. So here's a fun thing. In spring of 2018, I looked around the room in spring of 2018, and I said, boy, there's a lot of ladies in here. I wonder what the numbers are. So we actually did a deeper dive, and we hit 65%. And I went online. I'm part of the teaching track community. So I was asking the folks who are in my role, teaching the non-majors courses and major courses all around the country at Harvard and Michigan and Washington and Texas, all the big schools. And I said, is anybody even touching this number? And they said, Dan, we're in the 30s and 40s. We're, for our non-major course, the highest we're getting is like 40. Nobody's at 65. So you may be the highest in the nation. So I don't have the definitive answer, but I believe that was the highest in the nation that semester. And we continue to be well above 50% every semester since then. And part of that, by the way, is due to a culture of teaching at Berkeley that allows teachers to teach students to teach other students. So this is a delightful set of portraits of my staff. I like to take portraits of my staff so they can use for LinkedIn and for their own Facebook things. So these are the portraits of all the young women who have, not all, but a large number of young women who joined our staff. So it's just so inspiring to a young freshman who's taking CS10 to look up who is my head TA, who is my reader, who's my TA, and have them look like them. Representation is really, really important. So we need to do better with the students of color, but in terms of women, we're doing very, very well in terms of the list of our student staff support. But I also want to ground this back in the national space. So BJC is one of the classes that's offered in high school. I'll talk about from some RPD in a second. But if I look at the national numbers, thanks to APCS principals, the total number of female students has just, look at this. Like, it wasn't moving. It wasn't moving for so many years, less than 5,000. And this number is growing exponentially every year. And I can't wait to see the 2019 numbers. Oh, sorry, 2020 numbers. This isn't even updated. The 2019 numbers are even higher still. It continued up as well. And the URM numbers, the students of color, are also coming to this course in droves. So look at these numbers. Again, not ever moving for so many years, just trickling up. And look at this. Look at the difference between both CS being hot again. That's exciting as well. But I think that addition to the CS principles to this population, but not just the total number of students we're reaching, but also the percentage. And obviously we have a lot of work to do. This number is nowhere near 50% here. And this number is getting near, the national number that we're seeing, but we're not there yet. So we still have some work to do, but the number is climbing and we're doing well with that. So that's exciting. There's a deeper conversation, which is you can put the class out there, you can have the students take the class, but there's a deeper conversation about the performance in the class. If you look at the pass rates for Asian young men is in the 80%, and the pass rates for students, young women of color is in the 30 and 40%. So there's still a gap in terms of performance. We need to resolve that, but that's obviously we can just chalk up to institutional inequities, 400 years of institutional inequities to that, but we still need to do better in terms of that. So not just reaching the students, but also having them succeed as well. So we got to talk about that at some other stage. So this is actually part of the reality. The new reality is computer science is hot. They're rushing in record numbers to take CS. The CRA just did a Generation CS study. The Computing Research Association did a study of the students coming into campus. This is New York Times, but they find that most CS programs have had their enrollment of students multiplied by 4, so 400% of what it was in the low times about 2008 or so. So in 10 years, 10 or 11, 12 years, the number of undergraduates have grown about a factor of 4. If you look at here, it says, this is 30,000, and we're looking at maybe 120-ish. So that's still a factor of 4. At UC Berkeley, the number is 14. I'll say it again, 14. We are 14 times bigger in our CS program, Letters and Science, than we were here in 11 years. 14. So the reality is we're crunched. It's going to get worse before it gets better. The number of PhD candidates is here. So, the number of faculty in CS is not growing. Campuses are not expanding their CS programs. We got 2 new slots this year, and back in the low points of 2018, 2008, we got 2 new slots. So they're not funding us. They're not allowing us to grow our program to meet this demand. So almost everybody across the campus in the CS programs are being overworked with this now increased teaching load of a factor of 4. Nationally, what they're doing is they're adding more teaching professors. They're adding more Unit 18 lecturers to support that, and we've done some of that as well. That does work to stem a little bit of that, but there are still issues. We thankfully have, and many of you know the union grievance about 8-hour TAs now have to be paid tuition remission as well. So that's going to challenge our budgets for that. But that was a way that we were dealing with the fact that we were probably the largest, on the ground zero of some of this boom. Anyway, so just talking about that, there's still part of the issues. The reason I bring this up on this slide is, as much as we're trying to, this slide is about let's get CS into K-12, and all of a sudden a ton of students get into K-12, fall in love with CS, and try to get into the program, and are rejected into the program because we have to put GPA caps and we have to do these things. So CS is hot in everywhere. CS is hot for undergrad. CS is hot in high school. How are we as a group of faculty, as a department, as a college, going to address the fact that there's a stampede of students who are getting fired up around CS in K-12 who are not going to be able to get into our programs if our current programs, if there's no room in the current program. So there's an issue there. Some of our recognition from our success. So as I mentioned, Moju gave a little tweet on Twitter and got some calls. So we were featured in 2014 on the front cover of the Chronicle to talk about some of our success. TechCrunch picked it up, talking about some of our success as well. Slate picked it up as well. Hacker News. I'm starting to learn that many of these are the same version of the same article, just rewritten, but the same exact article. So this says TechCrunch. So Hacker News is really just re-forwarding TechCrunch. The Mercury News actually got on it. Mike Cassidy was a big proponent of women in computing at that time, back in 2014. So we wrote a couple articles about that, and he wrote another article later about supporting our students. So we didn't just keep this good thing to ourselves. We wanted to share this with the community. So this is an example of the 650 teachers we've reached across the United States. These computers are somewhat the places we've offered PD opportunities, so people would fly or drive into these locations where we have these all across the country. We're excited to see such a growing network of teachers and professors. I say professors, these aren't just the universities, these are the computers are the locations of the PD work, but there are also universities where they're teaching BJC. And we're delighted to share our curriculum. It's open source, it's Creative Commons. Anybody can teach BJC if they'd like to for free, not a single dime. And by the way, I didn't mention this, that all the things in CS10 are free. We're not trying to do this to sell a book. We try to give everything away. And so every single element of CS10 and BJC is free. So there's no dollar adoption you have to pay, which is not true for all curriculum. There are some curriculum. Project Lead the Way is one that's a high, the sustainability, you got to get some money in to pay the staff. And so Project Lead the Way charges schools money. We just give it away. So thinking about sustainability is something we're continuing to explore. This is an example of a PD opportunity that we had at Berkeley. This is the Wozniak Lounge. These are some of our family. And what's nice is to see people who are part of our early PD. This is Efrain Lopez. This is Emmanuel Onyadar. This is Josh Paley. These folks have become our master teachers. So these folks are now going out around the country and offering, this is Parisa Safar, offering our PD around the country. So it's delighted to see so many of the people in our early PD actually be leaders and take BJC with them as we're set. It used to be Tiffany, Brian, and myself offering all the PD, and now it's actually the teachers themselves who are leading the PD, and we just sit at home and try to support and coordinate them as much as we can and support them. I also want to mention we're going international. This is Peru. This is a picture of the Peruvian University of Peru. And this is Laura Berganahi and Rafael Felix. These are part of our CS10 TAs who were flown into Peru thanks to some of their initiatives to teach BJC to their teachers and their students as well. So we're excited to go international. This last summer, I just returned from Pune, India. So these are a group of Indian teachers we ended up working with for a week. Delighted. Ken Montgomery, many know, he was the mic man when he was undergraduate here. He now works for an Indian company, and so he helped bring us in to that company to do PD with their teachers. Delightful. I want to mention that we also gave back, so I make sure I definitely mention that EDC has been part of our family, helping us write that curriculum, helping us high schoolify our curriculum. We certainly learned our lesson that it isn't just enough to take our CS10 course at Berkeley and give it to teachers and say, go. It's a lecture-heavy course. We still have 4 hours of lab. We still keep the lab-centric element of it. But we can't just hand that to teachers and say, go. We have to really soften it up, more scaffolding, more differential learning, all the things that we will to make it easier. So we got a big grant, BJC in New York City. We call this BJC for New York City. New York City, who just today is their first day on a holiday. They're taking a break from face-to-face classes, and how they're able, there's a whole other conversation of how you're able to provide online learning opportunities for, here's 70% of New York City students are of color. It's delightful diversity. Actually, in some ways it's not diverse because an entire school would be a minority school without a single non-minority person in that school. So it's like majority minority. So there's not as much spread of that. There are often clusters of that in Spanish Harlem and Bronx and where I'm from. I was born in New York City, and Brian and I were both. So in a way, this grant was really giving back to our hometown. National Science Foundation, Jan Cooney was helpful in making this happen, but delighted to have this diversity to bring it back. And it's by 2020, by the way, we upped this number. We built a machine by working with the Department of Education and public-private partnerships. The idea is that New York City helped build a machine of training. We helped work with them, and then we left. And now they are continuing every summer teaching new students, new teachers in BJC without help from us at all, which is delightful. So that machine really just fired up, and NYC DOE is helping run it. But giving back was really key to this. And so we were able to reach, again, 650 total teachers and 200 out of New York City. Really delighted about that. We also decided, this is a couple of years ago, we got a grant from edX to bring this, to make a SPOC. You know, when the whole movement to go online was there, we said, what do we do for a student who's in a high school that has no high school teacher? Can't we support that person? So we got some money from edX and from the Harper Dean Foundation to build what Armando Fox, the Carl Karlstrom award winner, called a SPOC, a small private online course. So that idea is that we made all these resources. You know, we filmed all our lectures. We gave all of our labs away. It was really lab centric, so that worked really well. Moving to the online learning. Our online resources can be thought of as an ebook. If you think about this online course in the SPOC, the idea is the teacher can take the pieces they want of it. You know, they can mute some parts of it. They can brand their parts with their logo. You can add your own videos to it. But this is essentially, it's a resource you could use like an ebook. We did it for 3 years. We had 16,000 learners at its peak, which was very exciting. Although many of these learners were just kind of, you know, dipping their toe into it. It was a year-long course. We think it's one of the longest edX courses that exists. Most courses are 6, 8, 10 weeks max. This was an entire year. It's supposed to be a high school year. Started open in September. It closed in May. And then after we ran it with a lot of support, we basically leave the resources up there, but we just leave it as a self-paced course for now. Almost done. Almost on my last slide. What are the keys to the course? I got interviewed by a couple of folks to summarize what we learned from it. And so these are the things we learned from the process in 10 years. We had pair projects. The most important, okay, I'll say not the most important. The thing that students get engaged with the most, we found, is the create performance task. The way that the AP Computer Science Principles course is assessed is it used to be 2 performance tasks. One was an explore performance task. One was a create. Explore was about doing some research on a computing innovation like, 3D printing, and reading and writing about, you know, the positive benefits, the negative benefits, what are the side effects. And then there's a create performance task where the students pick a topic they want, make a game, make a tutorial, make a data analysis tool. And they build that project with a partner. So that pair programming was really, really key. So pair programming is really critical. We have pair programming in every single lab and as well in the projects. And just like CS principles, students choose their own projects. And many times this isn't being done across the campus, and across the country. People in CS1 still don't, in our own 61A, we still don't have pair projects that the students choose themselves. Partly is it's really hard to have a rubric that's very fair. As you know, that many students have to pass a bar of a GPA bar to get into our major. And so having some part of their grade that has a soft, squishy rubric people aren't comfortable with, you know, let's just have one, everyone does the same thing. It's easier to measure on the same yardstick, but that doesn't let them have their own agency, own interests. But CS10 is not part of those classes that are counted for the major. So students could use their own projects to great success. We certainly care about the social implications of computing. We talked about that. We use Blown to Bits as a book, as well as websites and, you know, interesting new things that we're finding online as resources, as free resources. And by the way, Blown to Bits book is also available as a free resource. It's a free PDF you can download at bitsbook.com. So they read and write about it. They actually read and write about it. They you know, pick a topic that you learned and go deeper in it, or pick a controversial topic and pick either the pro or the con side and argue that case. So we actually have them reading and writing their own assignments. So they actually share them. And so the idea is they submit, you know, about a page or two of an essay, and then students have to submit them on Piazza and then read the essay before them and read the essay after them, you know, in a list of a follow-up. You know, you can do follow-up in a linear way. So you have to read the 2 essays above and beyond. And then, because every submission you get to see the topic, then you pick one of the third one, which is a topic that you thought was interesting. Maybe someone's writing about privacy and big data and data breaches, and that's interesting to you. So you read that one as well. And you're supposed to provide commentary. And so we give them grades and we give them credit for doing that commentary as well. Not just reading it passively, but reading it and then responding back. Kind of like a forum, like an online forum where you might have comments in the bottom of a New York Times article, that kind of thing. I mentioned everything in the class is free. Readers, clickers, all that. We use clickers in CS10. We actually got a grant, an instructional technology grant, to be able to support that. So we use to try to do active learning as much as we can with clickers in class. And we have peer instruction as well, where we pause, we ask a question, and then they vote, and then they talk to their neighbors, and then they vote again after coming to consensus. We believe the Mike Clancy version, the Mike Clancy and Marshall Lynn model of having lab-centric instruction. So our 4 hours of lab a week is among the highest on campus. We feel this is where the real learning happens. We have 2 hours of lecture, 4 hours of lab, and 1 hour of discussion to summarize the week. And so those 7 hours are the most contact hours on the entire campus. When we were building CS10, we actually said, well, what's the most contact hours we could have? And they said, well, some chemistry course has 7 hours. We said, oh, we'll take 7. I'll take 8 or 9. And what that means is there's less time for the students to kind of be beating their head against the wall as they're feeling frustrated. They're actually learning and doing that in lab. We'll have lots of labs that are work on your project in lab, and our TAs are there to help them. So it's great. I mentioned before the opportunity, the cultural sense of CS where students are lab assistants. We now call them academic interns, and they're supporting by giving back, and they get credit for that support. We believe the programming language being graphical makes a difference. It's also quite pretty, the different colors, not just graphical all being gray, but it's quite pretty. We also don't think this is dumbed down. There are no typos. You cannot have a typo in this. The syntax errors are gone. There are still semantic and logical errors. Obviously, you can do the wrong thing. If I wanted to double, I could do triple, and it doesn't work for my salaries before, but the syntax errors are gone, which is nice. And we really think that the course and curriculum does capture the beauty and joy of computing. We have been misquoted as some people online believe that although the only thing we did to our non-majors course, CSforALL, before was just change the name, and we got the success. That's completely false. We kept the scheme element, we kept recursion and higher order functions, but we changed about 1,000 other things. We brought in more social implications. We had no social implications of computing in 3L. We did that. So we did a lot of things, but people online somehow think that it's only the name change. Like Papert, we believe that hard fun is an explicit learning objective. We say to our students on day one, this course may be the hardest thing you've taken before, because these are non-majors, never taken a CS course before. In fact, we actually strongly discourage anybody who's taken a CS course before to leave our course and take Data 8 or 6.2a. We want to leave the people in the room, people who feel safe to be among students who have never coded before. So we try to scare those folks away and encourage them to take other courses. Although we don't kick them out, but we strongly encourage them to leave. So the idea is that hard fun, this course is going to be the hardest you've ever taken, a harder course you've ever taken in terms of stretching your brain in different ways, but you're supposed to have fun while doing that. So it should be fun, especially when you get things working. It's a lot of fun. And this is my last slide. In summary, the lessons we've learned that we would share with other curriculum providers are that graphical languages at the intro level certainly do lower beginner frustration. You can teach powerful ideas in CS0, functions as data, recursion, concurrency. We're teaching all these things at a CS0 level to 16-year-olds, and it's working. We're excited about that. We believe the functional approach to programming versus an iterative or an object-oriented approach, the fact that CSA is taught in Java, which is an object-oriented programming language, is really broken. There are just too many hard things to learn at a time. So we really feel that CS Principles is the right way to start, even though the College Board won't let us officially declare that CS Principles should live before CSA. We think that's the right model. We believe that you should bring CS Computing the News to every course to ground it. This includes all CS courses. I've talked to other faculty about this, and they said, well, there's no time, they're not comfortable doing it. They're not used to doing it. But if you get into doing it, you get into bringing these slides in every single day. So every lecture you start with a Computing the News to ground. And if you can tie it into your course material, even better. And certainly celebrating diversity of our students. We want to celebrate and bring everyone in. We're part of the CSforALL consortium for a reason. We strongly believe that everyone can do it. This is an equity issue. We need to bring CS, but not just offer it. We still need to think about, the only way to really bring it to everybody, by the way, many folks say, just offer a course. If you have a course in every high school in the country, you've succeeded. No, because many students of color, many women, young women wouldn't choose to take that course. So what Brenda Wilkerson has done is to require, when she was at Chicago, she required it. She required a course in computing of every major to graduate high school. So we certainly celebrate the big tent, and we believe that maybe going forward from the state advocacy point of view, you have to require a course in CS. Although there's a zero-sum game in high school, and so you have to think about who you're pushing out to get that to work. But we certainly don't believe that it's about a weeder and weeding people out as a gatekeeper. This is about a Big Ten approach. In summary, CS10 has been transformational for many, many people. 20,000 students reach if you add up all the people on BJCX. This is not just us. We stand on the shoulders of giants. We think the CS Principles framework is dynamite. Scratch is an outstanding programming language that we just built upon. Blown to Bits is an outstanding resource book we just referenced. Our summer PD is 650, and we're growing every year. I think we're looking at another 50 or 100 this coming summer, although doing online would be a challenge, I think. And the future is so bright that we have to wear shades. Folks, thank you so much. I'll stop sharing and take questions. Wow, a lot of people. My goodness. Great. Golf clap, golf clap. All right.
So you can unmute yourself and speak up, or you can type a question into the chat.
And sorry for, I try to end it for about an hour, and sorry for running over a little bit for that. I can also make these slides available, by the way. Hi, Marsha. Unmute. There we go.
So many choices. Thank you so much, Dan. This is really fabulous. It's so inspiring. I'm curious about what the research issues that you're looking at now. I mean, you've really made progress in diversity and in attracting women and in making the course more accessible, but there's always more questions, and I'm especially interested in underrepresented minorities, which is an issue that we're all facing in the technology area.
Sure, great question. So I'll tell you where our initiatives are going. So this is, I'm not answering your question directly, I'll eventually get there, but the initiatives we're going now, people have said to me, Dan, this is your first act, what's your second act? The second act is we're going to middle school, some of the questions are, research questions are, how much of this can translate down to middle school? Can we make an effective middle school curriculum to teach some of the things that are part of the CSTA standards, the middle school standards? And can we teach functions as data? I think recursion might be a little too early, but how much of the elements, of core elements of BJC can we bring to middle school? So I'm working with that. We're also excited about media as data as a place. This is some of Mark Gusdial's work, computational media. So can we actually use Snap, and can we use map to, can you map over all the pixels? I have a 2 or 3 line program that can map over all the pixels of a picture and change it from red to green to blue. It's just the same map that they're using. And so I've done this for middle school students, and my local group, now I gotta say my group of 10 students are all like an advanced group, so that's not an average group of middle school kids. It's kind of kids who are on the top of their class, but they're getting it. So the question is how much of that would work for general class. We're also going international. So some of the questions are how much, I mentioned that Snap is international. We're working with a group in Guatemala, an edX group in Guatemala, to transfer our curriculum internationally. And our PD is now going international. So we have 6 or 7 people, part of our master teachers, who speak Spanish fluently. So what would it mean to take BJC, what's lost and what's preserved as we now have full Spanish immersion PD? What happens there, and what are the benefits to there? I really believe that you shouldn't, a rural student is never going to learn English if they're, you shouldn't need to learn English to be a computer scientist. But so many of the languages don't. I mean, Python is Python. There is no Spanish equivalent of Python. You need to learn the WHILE, if even, that character set isn't even your natural language, your local language. So I disagree with that. I think there should be a way to do Python that's fully immersive. So BJC may be fully immersive. We're excited going there. We also want to think about curriculum. So a lot of this has been curriculum design. It's been it's funny, it's been a little bit more development than the research angle, the development of the course and the curriculum, the PD structure and all of that. And we're asking questions, how does that work? Can you scale? Can you bring this to New York City? Can they build their own machinery? All those things are yeses. So thinking about what class we would have after this, could you replace APCSA, which we think is really broken, with kind of BJC Part 2, or could there be a course that teaches object-oriented programming, if that's the goal in this first course for majors, that doesn't have to use Java? Could there be a blocks-based version that teaches the OOP elements? And so the questions you could ask around that are interesting as well. We also, there's another element I mentioned, I think I might have mentioned it when I introduced myself a couple weeks ago. We're thinking about writing exam generators. Could you so CS10 is going to be one of the first pilots for Armando, and I hope Armando gives a talk soon on this, for Armando Fox's initiative about thinking about Craig Zillis's model of a computer-based testing facility. Could you have a facility on campus that allows every student to just drop in, take any mini exam, like Khan Academy, or like the mini quizzes we've had in some of the online work you have. So could you have these mini quizzes be able to be taken every day, every week? And so you don't have to have any exams anymore. You have these little mini assessments that are joyful. If you mess them up today and you get them right the next day, you don't lose any points. And so you can have full clobberability for that. The folks who've done this in UIUC have said you have to have So I believe in full club. Every course I've ever had, if you take a first midterm or take a second midterm, your second midterm is higher than your first, we completely overwrite the first midterm. And what they found in CBTF, where they have an exam every week, they allow kids every week. And they say, unless you have the early week count into the final grade in some way, they don't study at all. They'll say, well, I'll learn it next week. And then they keep saying, I'll learn it next week. And we saw some of that with Mike Clancy and with the Self-Paced Center, where students wouldn't ever finish because they say, there's no deadline ever. So if there's no deadlines, I'll just keep putting it off and putting it off. Or other things that have deadlines that are, four units of a graded course versus 1 unit of a non-pass, not pass course, they never prioritize the pass, not pass course. So people get to the end of the semester and they haven't done anything in Self-Paced Center. So you need to put something that kicks them in the butt to actually get them to do some work. So we have to think about how you do that if we have this continual thing. So CS10 is going to be a model for that, because the concept CS are easy enough to auto-generate. We've actually made some progress in auto-generating snap pictures, because they're pictures. You have to kind of auto-generate the pictures themselves by generating the XML file and then rendering those pictures. So we're actually working with Armando to be one of the early pilots for the CBTF, to bring in their Prairie Learn. This is UIUC's Prairie Learn system, to merge that with B courses, so you'd have these mini quizzes. So actually most of my research interest is less on what BJC does. I'm mostly curriculum developing BJC and doing the middle school piece. I got some funding to do that. But really, in terms of the research questions I want to ask are, what does the exam generation look like if you had continual assessment like Khan Academy every single day? So that's the thing that I'm mostly excited about, is thinking about that and working with Armando and maybe thinking about how to bring this to the campus as well. So that's exciting as well.
Yeah, well, it's sort of like embedded assessment is a permanent way to learn.
Yeah.
We used to call it continuous assessment back in wherever the dinosaurs and I were around, according to my kids.
No. I mean, and the idea is that you're never penalized. It's never like there's no stress. You just take it. There's a little quiz, and if you get it right, great. But you can't just luck out, get it right. And I say you got mastery. You have to kind of get 5 or 6 right in a row or something like this, and maybe get a little harder as you go on. But the idea is showing them a concept map that kind of gets green check boxes so that you can see where you are as it gets completed. It's really exciting to me to have the students know what they would know. Right now, students go into midterm thinking they know it, and then they bomb it. They thought they knew it, but they didn't really know it. But now you'll say, look, the system tells me that some other computer has told me that they think I have mastery. I love it to be able to know really what they know. So I'm excited about that as well. Samuel, yeah, go ahead.
Hi, Dan. Can you hear me okay?
Yes, great.
I work here in the Graduate School of Education with Lisa Kala. We were actually trying to set up a conversation with you. So a lot of what you've said today is very, very, very helpful. So thank you very much for that. And we're actually in our summer program at ATDP, we're going to be offering computer science principles for the first time.
Yay.
With Flint Christensen. I don't know if...
I know Flint very well.
Excellent.
Yeah.
I did have a question about a couple of the slides you showed.
Sure.
I saw the demographics for the APCS slide just skyrocketing. That's awesome.
Yeah.
I assume that's for both CSA and CSP
yes,
together?
that's code.org's analysis, and that's both CSA and CSP. That's right, yeah.
Okay. I was curious to know whether you had any demographic information about the next slide that you showed for, I think that was for undergrad.
Oh yeah, that's the New York Times.
Right.
Yeah,
or if you know anything about that, because I guess my what I'm curious about is how you see your courses contributing to representation in like higher ed and industry going forward.
Sure.
Like I know there's some concerns about especially in courses that I teach. I teach very similar sort of trying to be accessible and intro level, but I'm concerned about whether that takes, if you know what I mean.
Right. Yeah, sure. So I'll just speak locally, which is that we have different flows into our program. That you can enter a CS program through freshman admission, and it's the College of Engineering. You can also enter through the Letters and Science program. And so I do know that we've done surveys of people in 621A and B, that first 2 courses for major, and so many of the students are coming in through CS10. So many of them are finding CS through CS10 and then increase. So like the flow of our river into the flow of majors has helped the diversity of our program. And I think that's what's happening nationally, is that people are getting, turned on to CS through a CS0 course, and they're saying, how can I get any more of this? And then they're saying, well, take the first course for majors. And they would have never have taken that before that non-major course. So it's certainly helping. It isn't hurting it, certainly, with that. The hard thing is then, at least at Berkeley, you're now in a race. You're now in a race to get above a GPA cap. You've only had 4 months, 3 or 4 months of CS. You're now on a race to get above, the 3.3 GPA cap with students like my son, who I've been programming. He's been programming since he was 5, right? Is my kid of a CS professor, right? You'd guess he's been programming since he was 5. If he gets to Berkeley, it's not fair to have him in the same room as of my own CS10 students. It's just not fair. But that's what the reality would be. So there's still a challenge of getting those students to pass over the bar for that. I prefer Harvey-Mudd approach. Harvey-Mudd has 2 different CSAs, 621As. They have their first 2 courses. They call it the gold and the black, and they allow students who self-declare as having programmed before to be in the black, and their colors are gold. Like we're blue and gold, they're black and gold. But like both of those, they're equivalent. And the group that has programmed before just does a little bit more. They don't do any more. They do more kind of exploratory stuff, but they learn the same elements. But you're still in a room with only people who look like you and have people have the same experience with you. And they don't have issues of getting above a GPA for the major. So that's great for their CSA, and then there's no pressure. Whatever grade you get, you're still in the major. We have those issues. So I think there are larger questions about how we can grow our program, how we can get more support from campus or the state to stop turning people away from our program. Because I think it's a shame. Every student we turn away is a student who invent the next solution to something. It's just a shame we have to turn someone away. So that's a larger question. But in general, the answer is CS0 programs are feeding in and increasing diversity in that. But I don't have that number on that particular slide to see what that is. But as CS is getting hotter, the percentage of women is also going up nationwide. I don't know the exact numbers, but it's going up. It isn't flattening. It's not going down. It did dip in 2008, and it's going up, but it's not yet at 50. And it's relatively flat in many places. It's at 25%. So it's a shame that it isn't really moving that far. The needle is growing. You saw the AP numbers. It was growing up, but slowly, in the 20s, 30s. It's not really getting to the 40s yet. So we're still there. CS61A, our first course for majors, by the way, when I taught it last spring, I taught CS10 in the fall, and then I was able to teach the next course A in the spring. And maybe because I said, hey, folks, come with me and stay with me, like the Pied Piper effect, we had 47% women. They tell me 47% women, which is the highest, I think, in 618's history. So I feel real proud to be kind of, I was manning the lectern when that happened as well. So very happy with that, with those numbers as well.
Dan, I have another question.
Sure.
We're really interested in how we could meld computer science with science, where students leverage their understanding of science to learn computer science. And also we feel like the teachers that we're working with, who are middle school teachers, they have competence in their science, but they're really uncertain about computer science. So do you have some experience to help us think about this challenge?
We tried to put a grant together with Lawrence Hall of Sciences last year called Code Local. That the idea would be could we bring a couple of learning elements there? Could we bring a couple of curriculum modules that brought a little bit of BJC? I think a lot of it is data science. So if you bring in, let's measure something. Let's write a little app or something that measures the temperature or something, in your backyard or this or water in a plant, and you bring that back in, and then you're motivated with the students' data. So that's the thing that I've seen the most is when the students are able to record their own data and then do some analysis through the programming. So that's one technique that I think was exciting to us in our grant, and I think still has potential to make a difference in that's what people have talked about. How do you get CS into the high schools? There's 2 ways in, and way number 1 is you have an explicit course, like CS principles or something, and there are now middle school courses. Code.org offers a whole suite of CS discoveries of middle school courses that are dedicated CS courses, kind of for an elective. But the other way to get CS into, and not just to do it for good, but because students need to know these skills, is to infuse it into other programs. Can you infuse it into math? And there's a program called Bootstrap, which fuses CS into early math and early algebra. using Scheme actually. And so infusing into science classes would be, let's see how much we can do with data. How much, if we're not just doing CS for CS sake, you're doing CS to solve a problem you had to do anyway. You have to check the box that are required what you needed to do in that science class anyway, but you're doing it through CS because CS lets you automate. I mean, that part of CS is automating something that was tedious. Let's bring a computer and do something. And maybe Excel does 90% of it, which is a bummer, but maybe there are some things that learning a little bit of programming to do that. For example, mobile CSP is really very easy to build and make your own app. So you can make an app to make it easy to record data. So rather than having the sensors or having something to measure humidity or temperature or something, you actually make an app to do a survey, or you can walk around every time. Here's an example that I've heard. You make a very simple app. Everybody in the school downloads the app. And as you're walking your home, as you're literally walking home or taking your bus home, you look about it, and every time you see a billboard, you click a button if it's non-liquor based, you click a button if it's liquor based. So all of a sudden you notice, and let's say we all share this across the country, and you notice the kids that are in the inner city are finding, oh my God, look how many liquor ads as a percentage of all the billboards I see on my walk home versus the kids in the suburbs. That's a big difference. And so all of a sudden you have that numbers, you can look at that, you can analyze it, and you can use computers to do some processing of that. So letting the data be meaningful, letting the data be socially conscious, and letting the data have agency with the student where they care about the result of that. So I think all of those ways are ways to engage students, but also telling them that, you know what, you can either hand analyze this or hand compute something, or let's write a program to synthesize that. So both using computers in the service of, it was fun to make the app, it was fun to use the app, it was fun to record the data, how do you download it, how do you process it, what's the metadata associated with it, how do you then use that to do some visualizations and then have a report at the end. So all of those things that you used to do in science, could you do that with a computer helping you across those processes to both through the collection, to the visualization, the analysis as well. So you're trying to check the boxes you need to do anyway, but using computers to help you with all those processes, with all the things you got to do anyway.
Great, thank you.
Sure.
Wonderful.
My pleasure. Today is graduate school visit day. We're doing a virtual visit day. It's very exciting. We have, you know, hundreds of students now virtually visiting Berkeley. I have a hard stop at like 12:05, so I'll just make sure. just let you know that I have a student waiting to talk to me in a couple of minutes. But let's just check out. But I'm happy to take a couple more questions if we have one or two more. Sure.
And I have just a follow-up, actually.
Yeah, sure.
If that's okay. Following off of actually what Dr. Lin was saying, in terms of, and what you're saying about having, you know, computer science being just a tool, you know, for all different domains. I'm wondering, I don't know if this is really a question or a comment, but I'd like to know your thoughts in terms of just the purpose of computer science education. Yes.
Okay.
More broadly, because what I kind of see is that, you know, in terms of the demographics, even, education is very, you know, female heavy. And you have a lot of other domains where you have this. So I'm wondering if making computer science education more democratic, small d democratic, means that what we think of right now is you know, starting in a computer science class, going to learn how to program and going basically into computer engineering or software engineering. Would that be seen more as just of one potential pathway, whereas computer science education in general can be used as a tool, whether it's for science or for math or for social science?
Sure.
I don't know. I kind of see that potentially as like a schism in what we currently think of as the pipeline of a computer science education. And I don't know if that's a realistic.
No. I'll just a couple thoughts on that. So one, I think there's three purposes of what we're doing. Number one, we want to support students who don't realize that computing can be a career. We want to kind of whet their appetite, get them excited about this. People like me, I was always a CS person, I was always with puzzles and games, and I knew I was CS kind of from the beginning. But there may be students who are proficient and be amazing and increase the diversity of our field that don't realize that CS could be for them. So that's the kind of could I get people riled up in CS0 to then take CS1 to then be, and by the way, every graduation, every single May, it breaks my heart to think about what we're going to do with our own graduations, because every single May I have students who took CS0, got turned on to it, went through our undergraduate program, declared the major, became a major, and they tell me in tears how I've got a job at Facebook and Google and their parent, and I started to tear up thinking about the idea. I say, like, you changed my life. CS0, BJC changed my life. Thank you so much. And here's my stock options. Thanks to you. Like, I would never be here without you. So the CS for kind of getting the major space. Step 2, the CS as a tool that's used by everybody. This is the part that I can't imagine. Very, very few jobs, in 2030 and 2040 are going to not need a computer at some level. So the CS, if this is the only course you have, this is what part of the Hydra, not the Hydra, the two heads of the CS10 are. One is, could you have CS just be a tool, and could you get people engaged enough that if you needed to build an app to simulate something or do some, and so that's why it's not just about making games. It's about, can you do some data science? Can you do some map and combine to do some stuff there? Could you make an app if you needed to make an app? Could you do all those things? So CS is a tool for every career. That's 2. That's goal number 2. Goal number 3 is computational thinking. Thinking like a computer scientist. This is the kind of the Jeanette Wing spirit. Like, it's forget the programming. Throw programming under the bus. What if just thinking at scale and thinking about testing and thinking about performance and thinking about caching and some of the ideas that you have in CS, logical thinking, proving things. We think everybody needs to have the computational thinking. That's the kind of thing that we think is even a larger umbrella than coding. So coding is a part of that, but being able to be fluent computationally, thinking, that be able to run an estimate of how long something would take, order of growth, that's a process. Oh, you have a process of how to do something. Yeah, but as n scales, that doesn't scale. Our process doesn't scale. It's going to scale quadratically or exponentially. That's not a good solution then, because it doesn't scale. So thinking about elements of scale and caching and optimization and automation, all those things are, I think, things that we hope to teach in CS10 and BJC, and what we hope that people take away from this as well. So you're not only, if you're not a major, yes, you learn how to code, that's really nice, and you can use it as a tool, but you also learn how to think in a different way. There are many lectures we talk about societal implications of computing. We talk about what Facebook did. We talk about loss of privacy. So be able to have some fluency with that, I think is the other pieces. Forget the programming. This is about thinking in a way, everybody needs these skills in a modern society. So, people say, why is computer science? Why do you advocate this nationally? Why do you advocate this in high school? People need to think about these tools. People need to be fluent in the way. It's like thinking the way computer scientists think. It's like, I hate to say that we have a privileged way, but like, if you can program it, you see the world with a different lens. It's a way to look at the world. It's a lens to look at the world that is a really powerful lens. And we want to share that lens with everybody else. It's like mathematical thinking, right? It's like being fluent. It's like, being fluent with numbers is the same kind of thing. Being fluent with computers, being fluent with processes is the same kind of thing as the idea.
Yeah, that's a great note to end on. Thank you, Dan.
Thank you, everybody. That was fun.
You said your slides will be available?
I'll send them to you, Lauren. You maybe can send them out, or I can send everybody. Sure.
Excellent. Thank you.
I'll make a PDF. My pleasure.